Hello learners, welcome to Network Binary. My name is Zubair Zeti. In this video, I'm going to talk about essential protocol that we use in our daily life, but probably we never think about it. Learners, have you ever wondered when we turn on our devices such as a PC, a laptop, a mobile phone, how these devices get connected to the network? Whether you are using a wireless connection or maybe a wired connection using a LAN, even we don't assign the IP address on the devices. Well, the answer is we have the dynamic host configuration protocol, a DHCP protocol that assigns the IP address dynamically on the devices when the devices need an IP address. In this lecture, I'm going to cover at very first, we will see what is a DHCP. We will see why DHCP is needed. Then I'll be talking about IP assignment process. What happens between the devices when the machine or DHCP server they talk to each other to get an IP address or offer an IP address. Then I'll be talking about the DHCP relay agent, what happens when the DHCP server is on another network. Additionally, I'll show you the DHCP configuration. I have already packet tracer lab. I have designed the topology. I'll show you how to configure the DHCP pool on the Cisco route. And at the end of this video, you will have one question, or we will see key takeaway that we are going to take from this lecture. So let's get started. Learners, first question we have, what is a DHCP and why does it matter? In order to understand the DHCP, I have an example and we will try to understand why it is so much important. Just imagine you are the network engineer for any organization and you got a task, you have to assign the IP addresses, some other parameters like subnet mask, default gateway, or other parameters. Now you have to configure the IP addresses manually on the devices. So in order to do configuration, you have to go to the device location, you have to open the network settings, and then you have to put IP parameters, subnet mask, default gateway, etc. So you will be going to the device location, adding the IP address like 1.1, 1.2, 3, 4, 5, 6, 7, 8, and so on. Now, just look at this one. Assigning IP address on the devices, it takes time. It consumes time. It's not scalable. Apart from the time consumption, of course, doing configuration, there is a possibility that we can make some errors. What kind of errors? Like we can put an IP address twice on many devices, maybe. We can put invalid subnet mask. We can put invalid gateway IP address, or so on. So assigning IP address, it becomes the hectic task. It's very hard to maintain IP address manually. Now, what's the solution? How can I make this work efficient? Well, we have the dynamic host configuration protocol. We need a server, a particular server, or you can use a router, a Cisco router. You can enable, you can run the DHCP services on that. Again, you have a couple of devices you want to assign the IP address. Having the DHCP server and pool of IPv4 addresses, the server, it assigns the IP address dynamically to the devices whenever the client, whenever the devices they need for an IP address. Now, thanks to DHCP, that makes this work efficient and easy. Now, in DHCP, of course, we have a lot of things to learn. I have noted down something important information about it. First, we have the DHCP client and server model. DHCP is also known a client or a server model. What does it mean? When I say the DHCP client, it means I'm talking about the end devices such as a laptop, an IP phone, a computer, or maybe a Cisco router can be act as a DHCP client whenever it needs an IP address from the DHCP pool. On the other hand, we have the DHCP server. Again, this is a particular machine or Cisco router where we can run the DHCP services on that. So when I say the DHCP client, I'm talking about the devices and devices. When I say the DHCP server, I'm talking about the server. It has a pool of IPv4 address. So DHCP is also known the DHCP client and DHCP model. The other point is it works at transport layer at very first, application layer at very first. Well, if you have seen my previous video, I have explained the communication model. We got 7 layers: the application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. DHCP, that's the service that runs at very first at the application layer. Then it goes down to the transport layer, and at the transport layer, it uses the protocol, the UDP, user datagram protocol. Additionally, it uses the ports number 68 from the DHCP client side, and the destination port number, it uses the 67. So please note it down, these 2 points at the transport layer, UDP protocol with ports number 68 and 67. Now, one more question here. What DHCP offers apart from the IP address? Well, DHCP offers a lot of parameters, a lot of things like IP address, its subnet mask. Even you can add the default gateway, you can define the DNS server IP address, domain name, and other so much parameters. Now, when what happens when a client machine, a DHCP client or DHCP server, they talk to each other in order to get an IP address or offer an IP address from the server? Well, in this process, there are 4 steps. The first one or first message is called DHCP discover message. It means the client discovers for an IP address. The second message is DHCP offer message. What does it mean? It means the server machine, it offers an available IP address from its pool. The third point is DHCP request. DHCP request message, it is generated by the client machine. The client machine request for an IP address. Now, finally, the fourth message, the DHCP acknowledgement message, it is generated from the server, and the server, it makes sure that the IP address that was offered from my side, finally, it has been assigned to you. So this entire process is also known the DORA process, DORA, discover, offer, request, and acknowledgement. Now, learners, let's see each and every steps in detail. Just imagine you have the device that's your PC and you want to get an IP address. So when you turn on your device, that device generates the DHCP discover message. It says, hey, I'm looking for an IP address. And again, this is the broadcast communication. When I say the broadcast communication, we already have seen it uses the UDP protocol at the transport layer with the source client port number 68 and the destination, the DHCP server port number is 67. What about at network layer? What about at layer 2? Well, at network layer, inside the IP packet, it uses the source IP address because it has not any IP address at the moment. So it uses the reserved IP address, which is 0.0.0.0. Now, what about the destination IP address? Well, the destination IP address, it uses the local broadcast IP address, which is 255.255.255.255. Now, what about at layer 2? What about inside the layer 2 header? Inside the layer 2 header, the machine uses the source MAC address Of course, for sure, its own network interface card MAC address. But what about the destination MAC address? The destination MAC address, the machine is going to use the broadcast MAC address, which is all time FF, 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 and FF. That's why this communication is broadcast communication. This message is going to be flooded entire the same local area network or same the subnet. Now, what happens when your message it goes to the server, the DHCP discover message? When the DHCP discover message receives this message, it goes to the its own IP address pool where we have the available IP address. It takes the available IP address from the pool, maybe first one. In my example, it is using 192.168.1.1. This IP address is going to be offered towards the client. So server says, hey, I'm going to use the second step, the message, which is DHCP offer message, and I'm going to offer you 192.168.1.1. Again, this is the broadcast communication. It uses the source IP address, its own interface IP address. That's not the 0000, but the destination IP address, the same, the local broadcast IP address. Now, in the third step, when the client receives the offer message, it says, okay, you have offered this IP address, and I'm requesting you, please allow me to use this IP address. I'm sending the DHCP request message. Again, this is the broadcast communication, source IP 0000, destination IP, local broadcast IP address, and the inside the layer 2 header source MAC address, the unicast MAC address on the interface, and the destination MAC address is going to be broadcast MAC address. Now, what happens when this message goes to the server? Server says, okay, whatever the IP I have offered, let me bind that IP address to your MAC address in my DHCP database for record purpose. Now, finally, server says, okay, I'm going to acknowledge that the IP address which I offered to you, now you are allowed to use this IP address. So this entire process is called the TORA process, discover, offer, request, and acknowledgement. Now, learners, what happens when the DHCP server is not on the same network, on the same segment? What happens when the server is on the different network? Well, in this case, just look at this picture here. I have the local area network here, and these devices want an IP address from this server, and this server has IP address from 1.1 to 1.254. Now, the thing is that server is on the another network. We already know when the DHCP server, client, send any discover a message like the offer or request message, the router never switch or forward the broadcast messages to its own another interface. Router never do that. Now, how these messages are going to be forwarded towards the server? Well, we have something important, which we call it the relay agent. Actually, in this case, what we do, we use the router interface, which is facing towards the local area network. This interface receives the DHCP messages, and what it does, it receives the broadcast messages, and in order to forward this message toward the server, it changes the IP addresses inside the layer 3 header. It says, I'm going to change the source IP address. I'm going to use this interface IP address as this source IP address. And what about the destination IP address? The destination IP address, it uses the server IP address. Now, what is happening here? The agent relay, it is changing the broadcast communication into the unicast communication. Make sure there must be routing between the router, between the relay agent or your server. Once you have done the routing, the relay agent is going to make this communication happen. All right, learners. Now let's see what configuration do we use to configure the DHCP pool on our Cisco router and how we use the relay agent command. Well, in real industry, what we do, we basically save some IP addresses. We want that whenever the DHCP server receive any request or the discover message, the server should not offer the IP address from any range. So if you want to define the range that server should not offer uh, IP address, we have the command here on your screen, IP address, excluded address, and the range of the IPv4 address. It means the server is not going to offer these IP address from this range. Now, how to enable DHCP pool on our Cisco router? We have simple command, just type IP DHCP pool. You need to define the name, any name. I'm using npin. Then you have to define the network, what network you want to use. In my case, I'm using 1.0 with subnet mask. Additionally, you can define the gateway IP address, the IP address of your router interface, and the DNS server IP address, or you can define the domain name. Now, what about the relay agent? Well, to configure relay agent, you have to go to under the interface, like this interface here. This interface is going to be relay agent. So in this case, you have to go to under the interface mode, and then you have to use command IP address and the IP address of the server. This is the IP address where this relay agent is going to use as a destination IP address. Now, learners, let's see the how we can implement this configuration on our Cisco packet tracer. So let me explain this topology here. I have already designed this topology, and I'm going to explain this one here. In this topology, basically, we have this network, site A, I'm going to use 1.0 network. Site B, I'm going to use 4.0 network. And this is the main office. We have one server for this particular network. For this network, I'm going to use this router as a DHCP server. Let's dive into the configuration. So I have already assigned the IP address on my router. I have done the routing. I'm going to just show you how to enable the DHCP server on the router. So in order to do that, you need to go to the global configuration with the command config terminal, and we have command IP DHCP pool. Now you need to define the name of the pool. So I'm going to use here nbin, hit the enter button. Next, you need to define what network you want to use. In this case, I want to use 192.168.1.0 with the mask 255.255.255.0. Additionally, you can define the gateway IP address with the command default router. In my case, I'm using 192.168.1.254. Here you go. Now let me verify, are my devices able to get the IP address using the DHCP? So in order to get an IP address in Cisco Packet Tracer, just click on the desktop, go to the IP configuration section. You will be seeing two options, the static and the DHCP. Look at this one. My device already has got an IP address. Let me show you again. Click on the DHCP and wait for a few seconds. Yeah, again, it got the same IP address from the DHCP server, 192.168.1.1 with the subnet mask and the gateway IP address. That's easy. Now, learners, next thing that I'm going to explain here, which is the relay agent. So in my case, site B needs an IP address from this pool. This pool has the network for 192.168.1.4.0 here. Let me verify, do we have the pool on the server or not? In Cisco Packet Tracer, that's very easy. Just click on the server and go to the services. and look at the DHCP services. Do we have the pool? Let me verify. Yeah, we have a pool named server pool, and this pool contains the network 192.168.4.0 subnet mask, and I haven't defined the gateway IP address. Now, what I want that my devices from site B, they must get an IP address from the DHCP server. In this case, if you remember my slide about relay agent, this router, or especially this router interface, which is facing towards the LAN, it is going to be as my relay agent. I'm talking about this interface. So I need to go to the under the interface, just click on the device here, and the interface in my case, I'm using interface GIG0/2. Now the same command IP helper address, and you need to define the IP address of your server. So in my case, I'm using this server IP address 192.168.3.2. So I need to define here this IP address. Here you go. Amazing. Now let me verify by the command show running configuration. Just have a look here. We have the pool. We have other configuration as well. Yeah, we have some IP addresses configured. We have routing already here. And we have, just let me see that here. Yeah, under the interface, we got the command here, IP helper address and the IP address of the server. Okay, learner, let me see. Are my devices able to get an IP address from the server? Just click on the device and click on the desktop icon, go to the IP configuration, and click on the DHCP server. Let me see that. In first attempt, it failed. Let me verify again. Enable DHCP. Yeah, it got it. I've learned it. Just look at this one. My device got an IP address from the pool that is 192.168.4.1. Let me see that on the PC number 2. Is it able to get an IP address from the pool? Again, same IP configuration, DHCP, wait for a few seconds. Yeah, it got it. It got an IP address 192.168.4.0. So learner, this is the configuration making DHCP pool on Cisco router, or even you can use a particular server on different network, and you can make a router interface as a relay agent that makes your broadcast communication into the unicast communication. Now learners, it's time to talk about what key takeaway we got from this video. We have seen DHCP, that's amazing IP management protocol, effortless protocol. It uses the UDP protocol at the transport layer. And we have relay agent that works as a bridge that enable communication, your LAN or your, it bridges your communication from LAN to the server that is on different network. Now, we have the question here for you. Learners, you have to define, you have to answer what port number does DHCP uses at the transport layer using the UDP protocol. I hope this video has been informative for you. I'll see you in the next video. Bye-bye.